Hello and welcome back to Anton Math. Now we just finished up talking about experiments and events, so now we're going to talk about the multiplication principle, which is a tool that we use sometimes when we want to break an event down into simpler to use pieces. So it is sometimes useful to break down an experiment into parts, and when we do that we call it a compound experiment. So suppose the event A can occur in little a ways, the event B can occur in B ways, then the combination of the two events A and B can occur in AB ways. So this is called the multiplication principle, or the rule of product, and in set theoretic terminology, the combined event is A cross B. Right? We know if we have a set of size A and a set of size B and we take the cross product, the size of the cross product is A times B. Right? We call this the multiplication principle. Now, this principle only works if the events are independent. If the outcome of A affects the outcome of B, some combined results may be impossible. And we'll do an example of both cases where they're independent and they're not independent. But what independent really means is that for two events to be independent, I need to be able to have anything in the event B, any sample point in the event B must be possible for every single sample point in the event A, right? If I have a situation where, let's say, 1 occurs in event A, then I can't have something in event B happen, then they're not independent, and I'm not going to realize all of the combined events in A cross B. All right, so let's have an example where we have independence. So for example, a coin is flipped 3 times, and each time the result is recorded. So what is the sample space, and how many elements does it contain? So first, the sample space, S, is going to be all possible combinations of heads and tails in all of the different orders, right? We're recording it each time we flip the coin. We're recording if it's heads or tails. So we could have heads, heads, heads. We could have heads, heads, tails. Could have heads, tails, heads. Could have heads, tails, tails. Could have tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And we could have tails, tails, tails. Right, so it's very easy to see that the order of S is going to be equal to 8. But using the multiplication principle, let's say that each coin flip is represented by this event A, and the event A is heads or tails. Well, the order of the event A is 2. So using our multiplication principle, the order of S, since we're repeating A 3 times, this should be 2 times 2 times 2. Right? This 2 is my little a from my definition in the multiplication principle, and I'm really looking at A cross A cross A in this experiment, which we've broken down into now as a compound experiment. The simple experiment is A, the compound experiment is S, but here S can really be thought of as A cross A cross A, right? And of course this is just 8. So the multiplication principle works here. If we want to count the total number of combinations, we can just look at the event, the single event of flipping one coin, look at how many sample points are in that event, and then use the multiplication principle, multiplying those sample points by themselves 3 times, or the order of set A by itself 3 times, to get our order of S. Right? Here we wrote it all out so it was clear, but we didn't actually need to write it all out if we understand the multiplication principle. Now let's have another example where this doesn't quite follow. So let's repeat this previous example in the case where we stop flipping as soon as a head is obtained. So I'm still going to flip 3 coins. I'm going to record the result of each coin as soon as it's flipped, but if I get a head, I'm going to stop the example. Right? Now this is an example where I don't have independence. Right? If A is still my heads, tails, A is my simple event. If I get a heads in the first A, then the second A is going to be empty. Right? It's not independent of the first flip. So we see here I'm only going to have heads. If I get a heads the first time, I could get a tails first and then a heads. My first 2 flips could be tails, and my third flip could be heads. And I could have all 3 of my flips are tails, and I never get a head, so I never actually stop, right? So here the order of S is 4, not 8. So we see again the multiplication principle did not hold, right? The multiplication principle only holds if each of the simple events in our compound experiment are independent. Okay. Now in the next video we're going to talk about another method used for diagramming out all of these possibilities called a tree diagram. And a tree diagram is a method sometimes used to count all of the different possible combinations of events in these compound experiments. We'll see you there.